For weeks, the scientific world has held its breath, waiting, watching, wondering when China would finally release the data. Because while NASA, ISA, and every major Western observatory struggled with the blinding geometry of the sun and the dust storms sweeping across Earth's atmosphere, music, one spacecraft had the perfect vantage point. One machine stood above the noise. Music above the uncertainty, above the excuses, orbiting Mars in complete silence, armed with instruments built for clarity, not politics. And that machine was Tianwen-1. Tonight, the silence is broken. China has just released the first confirmed images of interstellar object, 3I/Atlas captured music, from Mars orbit taken during the period when every telescope on Earth was blind. These images combined with Tianwen-1's ultraviolet and dust monitoring music instruments reveal a side of 3I/Atlas we were never meant to see. A side that contradicts music, every prediction, defies every comet model, and amplifies the mystery surrounding the most unpredictable visitor our music solar system has ever received. These new images don't just fill the gap, they expose it. They show an object behaving in ways that are not only unexpected, music, but impossible. And now, with China's release, the world must confront a terrifying truth. 3I/Atlas may not be what we think it is, and someone outside Earth saw it first. This is the story of the Mars images music that will force humanity to rethink everything we thought we understood about interstellar visitors. The document begins with the most important detail of all, geometry. At the moment, Earth-based observatories, music, lost visibility of 3I/Atlas. Tianwen-1 was in a perfectly aligned orbital segment that gave it a clean, unobstructed line of sight across interplanetary music space. No sunlight interference, no atmospheric scattering, no horizon obstruction. Music just a clear, silent viewpoint above the Martian sky. While NASA's telescopes, music, were blinded by solar proximity, and NDS fleet was forced to suspend direct music tracking, China spacecraft continued monitoring without interruption. The spacecraft's high-altitude orbit allowed it to observe 3I/Atlas as it moved through the critical period before perihelion, the period when comets show their true nature, fragmentation, tail morphology, energy output, and sublimation patterns. But what Tianwen-1 recorded wasn't the violent fragmentation music expected by Western models. It wasn't the disorganized breakup predicted by thermal stress. Music instead, it saw a structure, stable, bright, accelerating. And as the document music repeats, while Western telescopes saw nothing, Tianwen-1 saw everything. The entire mystery of 3I/Atlas turns on music, that simple fact. The first released frame from Tianwen-1 is not dramatic at first glance, a faint point with a slightly elongated envelope. But to scientists who understand what they're seeing, it's a revelation, and it shows a massive dust coma, not thinning or scattering, but thickening, stabilizing, forming a symmetrical plume around the object. Every visible music wavelength analysis from the Mars orbiter confirmed a dense cometary coma, a sunward-facing music jet structure, a tail that is already measurable from Mars orbit, a brightness significantly higher than expected. But the music real shock is this. The coma's brightness fluctuated in a periodic rhythm, not random, not chaotic, a pattern. And patterns in interstellar objects are never ignored. Tianwen-1's ultraviolet sensors recorded a spike in UV reflectivity that music corresponded perfectly with rotational models, except the amplitude was too high for a small native nucleus. Something was either spinning faster than predicted or reacting faster than physics allows. This was not a quiet comet. This was an active engine of energy, and China had the only camera pointed at it. As 3I/Atlas moved closer to the sun, European ground stations were fully blind. The solar elongation angle made direct imaging impossible. Earth was looking straight into sunlight. Any attempt to track the target would drown in glare. But orbiting Mars, Tianwen-1 had the one vantage point that avoided the solar obstruction. The document emphasizes a chilling phrase. Mars was the only eye left open. With every other observatory offline, Tianwen-1 captured the development of new jet structures in real time. It recorded the elongation of the comet's dust music tail and the formation of the Antacola, a stunning plume stretching millions of kilometers. The Antacola grew faster than early models predicted. Far faster. This wasn't simple ouching. This was directed release, forming coherent lines rather than chaotic spray. The document's authors note, if a comet behaves like this near the Sun, fragmentation must follow, but fragmentation was nowhere to be seen. This is the moment Earth lost control of the narrative and Mars became the only witness. The photometry from Tianwen-1 shows something astronomers immediately recognized as impossible. A brightness increase of 0.3 magnitudes, with no visible structural breakup, during a phase when fragmentation is mandatory under classical models. Yet the nucleus appears coherent and the coma consistent. This is the paradox that the document describes in nearly every section. 3 Atlas shows the energy profile of a shattered comet, but the structural profile of an intact one. And this is why Tianwen-1's images matter. They reveal the first contradiction in the laws of cometary physics. An object cannot produce jets at this magnitude without exposing surface area that no single body of its size possesses. Unless the object is hollow, or it has internal chambers, or it has a layered structure, or it is not a comet at all. This is the moment when every scientist reading the file realizes why China hesitated before releasing the images, because this is the kind of data that doesn't just generate controversy. It generates fear. Every instrument on board Tianwen-1 agreed on one thing. There is structure inside the coma. Not dust, not music noise, not artifacts. Structure. The document describes a dark ridge within the light envelope, a region of suppressed reflectivity music that should not exist if the nucleus were spherical or irregular. It is shaped, distinct, repeating across music exposures. The authors note its axial alignment relative to the jet and speculate whether this is a density fold, a thermal shadow, or a geometric occlusion.